Imagine you're driving in a new city, and your phone calmly tells you to turn left into 100 meters. You reach your destination perfectly, without ever looking at a map. That's the power of GPS, the global positioning system. But how does your phone know exactly where you are on the planet? Let's explore how GPS really works. The global positioning system is a network of satellites orbiting Earth. There are at least 24 main satellites, plus a few backups, positioned so that at any moment, at least 4 of them are visible from anywhere on Earth. These satellites constantly send out radio signals that include their location and the exact time. The signal was sent, your phone, car, or smartwatch receives these signals and uses them to figure out your position. The secret lies in measuring time. Radio waves travel at the speed of light. By checking how long it takes for a satellite's signal to reach your GPS receiver, your device can calculate how far away that satellite is. Imagine you're 20,000 kilometers from one satellite. That means you're somewhere on the surface of a giant invisible sphere around it. If you also know you're 19,000 kilometers from a second satellite, you're on the edge where those 2 spheres intersect. Add a third satellite, and you can narrow your position down to 2 points. Usually, 1 point is impossible, like deep in space, so your GPS selects the one on Earth. That's called trilateration. To get an even more precise reading, GPS receivers use signals from a 4th satellite. This 4th signal helps correct small timing errors in your device's internal clock. Because GPS accuracy depends on time measured in billionths of a second. Even the smallest clock error could mean hundreds of meters off. The satellites, however, use atomic clocks, some of the most accurate timekeepers in existence, which allows your GPS to calculate your position with incredible precision. Often within a few meters. Each satellite orbits about 20,000 kilometers above Earth and completes to full orbits every day. The entire network is maintained by the U.S. Space Force, and other countries operate their own systems too, like Russia's GLONASS, Europe's Galileo, and China's Beidou. Most modern devices combine these systems for even better accuracy. But how does GPS work when you're indoors or in a city full of tall buildings? Signals can bounce off walls or get blocked. So your device uses smart algorithms to filter out reflections and combine data from motion sensors and Wi-Fi networks. Some apps even use what's called assisted GPS or a GPS, which relies on nearby cell towers to help the system lock on faster. GPS isn't just for navigation. It's used in airplanes, ships, and even farming equipment. Delivery companies use it to track packages. Scientists use it to study earthquakes and tectonic plate movement. It is essential for timing in financial systems and cell networks. Even small differences in timing could affect global transactions and communications. Think about how incredible this is. You can stand anywhere on Earth, look at your phone, and know your exact location because dozens of satellites in space are all talking to you at the speed of light. It's a brilliant mix of physics, engineering, and math working perfectly in sync. So, the next time your GPS helps you find a new restaurant, remember there's a massive system of orbiting satellites and precise timing calculations making it all possible. Comment the next topic you want to learn.